section 8.1. This is going to be about volume of a cylinder, but not only are we going to be covering 8.1, we're also going to cover section 8.2 in this video, which is the volume of cones. I'm putting these two videos together because they're basically almost the exact same equation, and you basically work with them the same way, just plugging in numbers. So I'm going to go with some basic questions with you on this. Now, I also want you to understand something. Please be advised, the questions that I'm going through with you are actually going to be pretty, like I said, basic. And what's going to end up happening is in some of the problems that you're going to be getting, you're going to be taking and getting more application-based problems where you're going to be getting something that's asking you to take things a step farther than just calculating what's known as volume. And as you are probably already aware of, volume is basically how much space something takes up. You probably did that last year when you were working with boxes and stuff like that, calculating volume. Very simple for boxes is length times width times height. However, for a cylinder, when we went to calculate how much space it takes up, the equation is the volume of a cylinder is equal to pi r squared times height, where r represents the radius of our cylinder, basically this piece right here, the circle, the radius of the circle, and then h represents our height. If you know these two things, you know volume, all right? And it's straightforward. So the other thing that you need to kind of recall back, and it's not really anything, shouldn't be too difficult to remember, is you'll see some problems that might ask you to remember how to find circumference, which would be pi times diameter. Or you might have to find out what diameter is, which is 2 times my radius. So these things right here are not going to go away. They're actually going to be coming and haunting you on a few problems that you will see probably in your assignments. So don't let this slip away. So circumference is pi times diameter, and diameter is twice the radius. And if we're wanting to know volume of a cylinder, pi r squared times h. So just a little quick review on things. Now, let's just go ahead and get to a couple of questions. Pretty straightforward stuff. It says find the volume of a cylinder. Well, how do you do that? Well, we simply go V is equal to pi times r squared times height. That is my equation. Let's plug things in. V is equal to pi times my radius. Well, this right here gives me the length of my diameter. And how do you find radius? It's half the diameter, so that should be the number 6. All right, so the radius of here to here is 6 square times height, which is 5. All right, and now it's really easy stuff. Plug it into a calculator. We know that pi is going to be represented by 3.14, or you could use your pi key. In this case, let's just use 3.14. I'm going to multiply that by 6, and I'm going to square it using my square button, and then I'm going to multiply that by 5. I'm going to hit enter, and I am done. The volume of this thing is 565.2. Now here's the thing. Also, you probably remember this from 7th grade, to remember your units. What units was I working in? I was working in centimeters. And also, if you could recall from 7th grade, since I am working in volume, it's going to be centimeters cubed. Centimeters to the 3rd power, because I was basically multiplying centimeters 3 times. So the final answer is 565.2 centimeters. Now, it says round your answer to the nearest tenth, and it's already been done for us when we plugged it in, so we didn't have to do anything. All right, let's look at number 2. Same thing, find the volume. Volume is equal to pi times r squared times height. Plug in things, pi times 4, because it gives us a radius right here, square times a height of 10. And then we can work this all out. 3.14 times 4 square times 10, and I have 502.4 centimeters, not centimeters, we're in inches, my bad, inches cubed, all right? And that is my volume. All right, I'm going to do a couple of these other ones with you. It says find the missing dimension of the cylinder. Round your answer to the nearest whole number. So I'm looking for the height of this particular problem. So how do I go about doing that? Well, I use my equation. Volume equals pi times r squared times height. Let's plug in things we know. I know that my volume is 84. I know pi is going to be here. My radius in this case happens to be 3 because half of 6 is 3. So that's going to be 3 squared times h. Let's simplify this a little bit more. I have 84 is equal to pi times 9 times h. And I can simplify it one last time, and I can say 84 is equal to 9 pi times h. All right? My job is to get h by itself. We treat pi like a number. So what we can do now is I'm going to rewrite this to the side, and I'm going to say 84 divided by 9 pi is equal to h. Why did I do that? Because I was multiplying by 9 pi, I'm going to divide by 9 pi. And the reason why I'm doing that is to get h by itself. This is not changing anything you already know. This is going back to the SADMEP concept, getting h by itself, reversing your processes. Now that I've got it written out, I'm going to say 84 divide by 9, and I'm going to put this in parentheses. I'm going to say 9 times 3.14, and I'm going to put it in there like that. Hit enter, and I get 2.97, blah, 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 but it tells me to round my answer to the nearest whole, so it's about 3 inches in height. All right, let's do the next one together. This time, I'm actually looking for this measurement. I don't know what this is, so I'm trying to find out the diameter. Okay, so what do I need to do? Same concept. Volume is equal to pi r squared times height. I don't know what my radius is because I don't know what my diameter is, but I do know that volume is 650. I know that this is going to be pi times r squared times 13. Okay, so I can rewrite this to say 650 is equal to 13 pi times radius squared. All right, I am going to do just like I did a while ago. I'm going to try to get this r by itself, and I'm going to divide by the 13 pi on both sides. Okay, when I do, I'm going to get 650 divided by 13 pi is equal to r squared. Notice that I have an r squared here, not just r. We're going to come back to that in just a second. So let's plug this into a calculator. 650 divided by 13 times 3.14 times pi. Hit enter, and I get this wacky looking number. So I'm going to just kind of write that down for the sake of time. So I'm going to say 15.9 blah, 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 blah equals r squared. Now here's the issue. I do not have r by itself. This is saying that this 15.9 is equal to some number r multiplied by itself 2 times. So what I need to do is find what r is, and the easiest way to do that is when I am squaring a number, we want to do the opposite of squaring a number, and that's what we call square rooting. We're going to square root it, and this should be somewhat familiar. So we're going to find the square root of this number. How do we do that? I'm going to go second, and then I'm going to hit this x squared button, and it gives me my square root symbol. And then instead of typing in the 15.99 blah, 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 I'm going to hit second again, and then I'm going to put A and S, which is this button right here. And now it says the square root and answer. What the calculator is being told to do is to take that number, 15.999 blah, 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 and square root it. Hit enter. And I get that r is approximately 3.99. Or we can round that to say that r is actually 4 centimeters. Okay? So we found out what r is. But am I done? No, I'm not. I found what r is, but I didn't ask for a radius. I asked for the diameter. Well, remember, radius is half the diameter. So I can simply multiply this by 2 and say that the diameter of my cylinder is actually 8 centimeters. So that's my final answer. All right, number 5. It says, to make orange juice, the directions call for a can of OJ concentrate to be mixed with 3 cans of water. What's the volume of orange juice that you make? So basically what's happening here is I need to take this can of orange juice and then add another 3 cans of water to it. And those cans of water are the same size as my orange juice, okay? So what I need to do is simply this. I'm going to understand this concept. I have a can of orange juice and 3 cans of water. So if I can find the volume of this one can, I can find the volume of all of them, and I can simply multiply by 4. Because technically I have 4 cans of liquid that I'm using. So let's do it. Volume of orange juice is going to be pi r squared times height. Volume is equal to pi times r. In this case, it says that our diameter is 3, so it's going to be about 1.5 square times my height, which is 5. All right, let's plug that information in. 3.14 times 1.5 square times 5 gives me 35.325. All right, so that one can has a volume of this number, but I don't need one can. I need a can of orange juice and 3 cans of water to have a total of 4 different cans. So I can simply say times 4. And when I do, I get 141.3. So the final volume of orange juice is going to be 141.3 inches cubed. That is my final volume, all right? Because all I did a while ago was find the one can, which happened to be around 35, sorry, went off the screen, 0.325. That was for one can. All right? But I needed all 4. Now, let's move on to the next questions here, which is in section 8.2, and it's called volume of a cone. Well, same things. All you need to know is the height of the cone and the radius of the cone. With that, your equation is 1/3 pi r squared times height. So it's really identical to the equation that we were using a while ago, except I haven't multiplied it by 1/3. This is the reason why we can do it. If you took 3 of these cones and put them together, the volume of 3 cones would be the same thing as one cylinder. So if you had a cylinder, just kind of do it this concept, just so you can see. Here's your cylinder. And the radius happens to be the same as well as the height of this. So if this radius is the same as this radius and this height is the same as this height, you would need 3 cones to fill this cylinder up. Okay, that's what this fraction's telling you. It's 1/3 the size of a normal cylinder with that radius and that same height. That's the concept of the equation. But let's just use the equation. All right, and I'm probably not going to do all of these like I did on the other one. We'll just hit a couple concepts and I'll let you do the rest of your own for the sake of video time. So in this particular one, we have, something went wonky. All right, find the volume of the cone, round your area to the nearest tenth. So same concept, volume is equal to 1/3 pi times r squared times height. Let's plug things in we know. 1/3 times pi times my radius. Well, my diameter of this cone is 12, so that means that my radius has to be 6. And then my height of it is going to be 4. Now that I've got that, it's just a matter of using my calculator. I am going to say 1/3 times 3.14 times 6 squared times 4. Plugged it all in, hit enter, and I get that the volume is approximately, rounded to the nearest tenth, 150 point, and this is what I want you to stop. Your instinct is to probably say 150.7. Why is that the case? Because you're looking at this, I'm sorry it's a little faded in the screen here, you're looking at this and that 2 tells that 7 to stay the same. And normally you'd be right, but that's not quite the way this is going to work. Here's the reason why. This 0.72 is bigger than 0.7. And so this is actually smaller volume than what you really have. So in the real world, we would actually round this, breaking all the rules you've been told about rounding, to an 8. Here's the reason why. When we rounded down, we said that the volume is less than what it really is. And because of that, in the real world, by doing that, it would mess up a lot of things. Case in point, when I worked at PCS, they calculated air volume all the time when the acid tanks that we used to clean. And if we underestimated how big an acid tank was, it could actually be very dangerous because we have to make sure that those acid tanks have complete and proper airflow. So if we were off and we were not doing enough airflow, that means that the people inside of that tank weren't getting fresh air. So we always wanted to overestimate. So this breaks nearly every rule you have been told about rounding, is that you always round down. That's not entirely true because of the situation. In this case, we need to round up because we want to get the volume of what the cone could possibly be. By rounding down, we're undercutting what we know. All right, so just keep that in mind. Will I be nitpicky on this? No, not really, but it is something I want you to be aware of, and it's actually something that's a big deal later on in math, knowing how and when to round correctly. All right, so with that in mind, I'm going to let you do numbers 2 and 3 on your own. I think you get the idea of how this works. Go ahead and try that on your own. All right, what you should have gotten was for 2, 103.7 feet, and for number 3, 128.3 cubic centimeters. And I forgot to mention that in number 1, that should have been cubic meters. All right, numbers 4 and 5 are pretty much the same as what we've done before. This time we're solving for h. So again, volume is equal to 1/3 pi times r squared times height. Let's plug in the things we know. Volume equals 1/3 times 3.14, or basically pi, times my radius of 12 squared times height. Let's plug in all that information. It's going to give us a bunch of stuff. Oh, wait a minute. You know what? Pause. This is why I shouldn't be writing in pen. I didn't even write it. I messed up. I see something wrong. So let's slow this one down just a little bit, and we're going to kind of look at what's happening here. I didn't see this at first. Notice that it says volume is 300 pi. So I'm going to write this equation out again. Volume is equal to 1/3 pi r squared times height. Let's plug in what we know. 300 pi is equal to 1/3 pi times 12 squared times h. Let's complete this out. 300 pi is equal to, let's do 1. This time, instead of doing 3.14, we're going to leave the pi there. And so I'm going to say 1/3 times 12 squared. And that gives me 48. So this will gives me 48 pi times h. Now, since I'm trying to get h by itself, I'm going to divide 48 pi on both sides. When I do, this cancels out and this cancels out and leaves me with just h. Pi cancels out on this side, and 300 divided by 48 gives me 6.25. All right, and since it's telling me to round my answer to the nearest tenth, this is going to be 6.3 millimeters. And since it's adjusted distance, it's just going to be plain out millimeters. It's not going to be cubed or squared. All right, I'm going to let you do 5 on your own, see how you do. You should have gotten that the height was 3.0 centimeters. And now let's look at number 6. I actually had to look this up. It says, what is the volume of a catch and click cone? I didn't even know what a catch and click cone was. I'm able to find the volume of this thing pretty easy, but this is what a catch and click cone looks like. It's just a toy where you press a little button and it throws a ball up in the air and your job is to catch it. I've seen them before. I just haven't really played with them in so long. I tried to find a video of it, but I couldn't find a good video I could use. But anyway, moving on. How to find the volume of this thing? Pretty straightforward. Volume is equal to 1/3 pi times r squared times height. Let's plug in the things we know. 1/3 times pi times my radius, which is 2 square right here, times the height of my entire cone, happens to be 7. Let's plug everything in. 1/3 times pi, 3.14, times 2 squared, times a height of 7. Hit enter, and I am done. The volume of this thing is 29.4 when we round correctly. So, yes, again, your instinct's to go down to 3, but in this particular case, we need to go up. So 29.4, and that's going to be inches cubed. All right. In this particular case, we probably could have been okay with 29.3 just because of this being such a small number, but it's all right. And again, that's something that you're aggravating to you because I'm telling you to break a rule that you're so used to doing. Again, would I accept 29.3? Yes, but the better answer is 29.4. And that actually may pop up on the EOG. Just keep it up and keep it in your mind. All right, so that's pretty much it about volume and cones. All I have done, like I said, is just gone over the basic equations and how to use it. The problem that you're going to have is in the upcoming work that you've gotten assigned is you're going to have to take this basic information and take it farther on your own. Please don't hesitate to call me on some of these questions because some of those questions might stump you, and that's okay. They're meant to make you think. And that's it for this video. I'll talk to you in the next one. Bye-bye.